Hello, my name is İsmail Avcı.
My name is Cengiz Yurdakul and we are going to present our final project.
This is content parts. Firstly, I am going to talk about description of problem, aim of the project, realistic restrictions and condition in design. Then Cengizhan talks about design of the project, methodology, outputs, project schedule. In recent years, shopping has been a great economic income for brands that sell products. These products include materials, clothing, electronics, etc. It has different categories. This system can be overloaded because there is a lot of interest in this area. Different problems arise due to these loads. One of these is the queue problem that occurs during payment. The cashier payment system is very suitable for change with the developing technology today. In the project, we aim to provide a fast, cheap and convenient in-store payment system through deep learning. A system compatible with our technology that does not require payment, which facilitates realtors shopping in store and greatly improves the customer experience based model. These are our realistic restrictions and conditions in design. The most important of these for us, economic issue and productivity. For example, economic issue can reduce the workload in other areas by spending less time on the cash register of the staff. Due to decrease in workload, manpower requirements will decrease and salary expenditure will decrease. Productivity, since our project is similar to the system currently used, it is easier to adapt and can be produced because it can operate faster and cheaper than this system.
In this part, I am going to talk about design of the project. First part is creating dataset. Dataset is not taken ready. The pictures of the products were taken completely in accordance with the system. Due to the progress of the project, the background was set to black because detection will be made at the checkout. Then labeling was done. After this labeling, the product information which is bounding box coordinate is stored in CSV format. Then hyperparameters were determined by applying grid search methods to get better and faster results from the training. Finally, training was initiated. Now let's talk about our methodology. Our biggest goal is to feed the overall system with different algorithms for increased efficiency. The project has flexible architecture and can be integrated with new developments. While preparing dataset, we used augmentation method, which are rotating brightness, adding noise, etc. We used binary classifier that can be applied by placing the products one by one in the frame. Of course, these products must always be at the same points. We used alignment methods here. We used PCA algorithm to visualize our dataset. In this visualization, we were able to see the identity vectors of our dataset and analyze whether our dataset balanced or not. In this visualization, we found that our information loss was low as our variance value was around 90%, which made us happy. As our information loss is low, we have seen that we can turn to other methods on the dataset by calculating distance, which are Euclidean or cosine, with the Cannon algorithm. With all these algorithms, we prepare a demo as much as our model was trained. Let's take a look at our results. In this part, we will see our accuracy and loss graphs, visualization methods, PCA and Cannon algorithms, weights of our neurons with distribution and histogram graphs. Finally, we will see our detections. There are two types box classification loss. First one works on where the product is. Second works on which product is. As we seen in the figure, we are better at classifying the products. According to our analysis, the reason is our image. While the dataset was being prepared, the background of all images was set to the black, because the products would be detected only in checkout. As a result, we will start the training with images on different backgrounds and solve this problem. RPN loss is region proposal network loss. This loss means bunch of boxes that will be exempt by classifier and regressor to eventually check the occurrence of object. To be more precise, RPM predicts the possibility of anchor being background or foreground and refine the anchor. Background error shows itself here as well. When all these losses are collected, our total loss occurs. We got a memory error around 200,000 iteration and had to stop training. This is the reason for the fluctuation in that area. The loss and accuracy graphs of our binary classifier are like this. After these problems in the system are resolved, their availability will be tested. These results were obtained in the 500,000 steps of the training. We visualized in 2D and 3D using PCA algorithms, and visuals are like this. Using KNN, we can do whatever we want via TensorBoard or through scripts we write. Using TensorBoard, distance calculation, classification, 2D and 3D visualization can be done. And there are our perceptrons weight. We have 30-page distribution and histograms. These are only first layers graphs. All operations are ready as we planned at the beginning of the project. The only process we will do is to restart the training with a new dataset and fix the problems. And here is our detections. We see the background problem clearly in here. Finally, our sample video is here. Thanks for watching.